This question is given that which of the following circular rods, given rod of radius r and length L, each made up of same material and whose ends are maintained at same temperature, will conduct most heat. So over here we are considering a cylindrical shape object through which there will be a conduction of heat. Just say we are considering an object something like this. So and heat is flowing through this object. So if we are maintaining some temperature difference across its ends. So let's say its length is represented by nothing but L and its radius is nothing but R, and we are maintaining a temperature difference across its ends. So there will be a flow of heat energy from high temperature region to low temperature region. So our aim is to find out is if we are maintaining same temperature difference, which one will conduct most of the heat energy. So we can write this dq by dt is equal to Ka delta T divided by L. So we can write this dq by dt is equal to K into area of cross section, we can take it as something but pi r square, into delta T we can take it as something but difference in temperature delta T divided by length, we can take it as L. So we can write in this situation the value of K is a constant, same material, delta T is a constant, pi is a constant. We are basically changing this R and L. So we can write this dq by dt as directly proportional to r square and inversely proportional to L. So we can just put those values over here. So in the for option A, we can say that this dq by dt is directly proportional to r square by L. So r is given as something but 2r. So it is going to be something like directly proportional to 2r square divided by 2r the whole square. So we can write 2r square is nothing but 4r naught square divided by length is given as something but 2l naught. So we can write in the first situation is directly proportional to 2r square divided by L naught, like that in option B. If you are putting the value, what we'll get it is r is nothing but 2r over here. So this is 2r naught square divided by L is L naught. So this is directly proportional to 4r naught square divided by L naught. Like that in the third situation, if you are putting the value, we'll get as r over here is given as r naught. So it is r naught square divided by L is given as L naught. So we can write is directly proportional to r square divided by L naught. And in D option, it is given as nothing but r and 2L. So we can write is r naught square by 2L naught. So we'll get as it is half of r naught by L square, L naught. So over here it is something like 2, and over here it is 4 times of r naught by L. Over here it is 1 times of r naught by L, and here it is half of r naught by L. So we can write in the second situation, or in option B, we are getting maximum flow of heat energy.